Good morning, this is your Stat Sensei, Mr. Spensei, and we're going to go through a hypothesis test. We're going to just it's already been run, but we're going to do the parameter and the conditions and the conclusion. We've already run the test. So Professor Andy Neal measured the time in seconds required to catch a following meter stick for 12 randomly selected students, dominant hand and non-dominant hand. Professor Neal claims that the reaction time in an individual's dominant hand is less than the reaction time in their non-dominant hand. Professor Neal has 220 students. The difference in reaction time are normally distributed. All right. So looks like we have 12 students. That's pretty good. They were randomly selected. We're going to need to know that. He has a total of 220 students, and they're telling us this is normally distributed, which is important because our sample size looks to be less than 30. So we have paired data. Each one was tested twice. We have a dominant hand test and a non-dominant. And it says test an appropriate hypothesis and state your conclusion at a significance level of 0.05. And the claim is that the dominant hand time is less than the non-dominant. So the dominant is supposed to be faster. So we have a hypothesis, mu d, mean of the differences is 0, and it should always be 0 for a paired t-test. And here they said less because we said dominant minus non, so less time um, uh, for the dominant and more time for the non-dominant. So let's go ahead and write our parameter at this point. So let mu d equal the true population mean. We're interested in reaction time. Oh, mean of the differences. Because and why did we say differences? Well, we said differences because we're busy. We are ultimately going to subtract for each one, this minus this minus this. So we took a bunch of differences and then we took the average of those differences. The true population mean of the differences in reaction time. Having trouble spelling this morning. Reaction time. And then we went dominant hand minus non-dominant. We always have to show the or tell the order that we subtracted because that actually will impact our results, right? It tells us which way our hypothesis has to be run. And so since we already have our hypothesis, this not dominant minus non-dominant is consistent, and that's what we labeled up here. All right, our conditions. Well, we need a random sample. That's the first one. And they told us it was a random sample. They said we had a random sample and we had 12 students. So we had 12 pairs of 12 pairs, and that was given, right? The second thing, we need to say that the differences are independent. And that's reasonable to assume, especially since we took a random sample. 3, we need to be needs to be less than 10%. Well, n is 12, and 12 times 10 is 120. And that needs to be less than the total population of his students, and he has 220. And then the question is, are we normal by central limit theorem? And the answer is no, because our sample size is 12, okay? But they told us the differences were normal. Differences are normal, and that was a given. You didn't have to check. I mean, we didn't have to prove that. All right. So we've already run the test. We ran the test, we plugged in all our values, and we got a p-value of 0.009 and that's less, okay? And so since it's less, we're going to reject the null, so that's our decision, so we need to write our conclusion. So our conclusion is, we start off with our p-value. Our p-value is 0.009. What did we decide? We decided to reject the null. Why did we reject the null? We rejected the null because there is sufficient evidence. We have enough evidence. So there is sufficient evidence at our alpha level was established above as predetermined. Our alpha level of 0.05. To claim or to suggest that we need to restate our parameter that the true population mean of the differences in reaction time and we have to list how we did it. We went dominant minus non-dominant. Is now we need to go look at our hypothesis. Well, our hypothesis was less than 0. So is less than 0. All right, that's in statistical terms. So what is it in real terms? Well, basically, we rejected no difference, and we said the dominant hand does take less time. That's what we chose. So we're going to say that real simply. The dominant hand is faster. And appears faster. All right. So in this case, we actually had significant evidence or substantial evidence, enough evidence to say the dominant hand appears faster. All righty, appreciate you watching, and I hope to see you on the next one. Thank you.